Hey, what's up everybody? Mr. Tannen here, about to factor some non-monic trinomials for you. So, this came up in class. Let me break it down really quick. If you haven't already, put this video on double speed because I tend to speak slowly, and that's what I recommend. I often like to do that when I'm watching math videos on the YouTubes. So check it out. I got a few problems here. I'm going to pull these over here. So hopefully you're pretty good with factoring what I would call a monic trinomial. Something along these lines. Hopefully you're familiar with what we specify in terms of A, B, and C, because I'll be using A, B, and C to talk about the coefficient of the quadratic term x squared, the linear term bx, and c. We're only going to be talking about the coefficients, though, the values. We don't necessarily always bring the x squared with us. So I think you're familiar here with this format, I hope. If I'm to factor this into two binomials, I need to see what are the factors of negative 35 that add to positive 2. So I could start listing my factors of negative 35, and eventually I'll end up, well, negative 5 and 7. Those multiply, so I could then factor it to x minus 5 times x plus 7. That's my bread and butter monic factoring. It gets a bit more complex when I have a coefficient of my x squared terms that's not 1, or an a that is an integer other than 1. So let me pull up a good example here. So I'm going to go ahead and give you one along these lines. So I'm going to call it a 3, so that we call that one number 1. A 3x squared minus a 28x plus 9. So when I was in school, I just learned to basically break it down and think about it till you found the solution. Make sense of it, which is a great strategy if that works for you. However, what I wanted to do in this video was show the strategic method, which I like to call the box method, which will get you to an answer using this process of thinking about the trinomial as the 4 terms you would get in what is typically called FOIL. So to do this box method, you start by putting the 3x squared, or the first term, the 3x squared, the ax squared term, and the c term. And notice I put the plus 9. So now negative 28, how would that play in? Well, it still is the same process, but now I want to find what are the factors, instead of just finding the factors of c as I did above, right? I just found the factors of negative 35. I need to find the factors of a times c, or ac, that add to b. That's essentially what I'm doing differently. Again, you could even think of this like that, but since a was 1, it always ends up being the case that you just could think about it as c. But for my non-monic, what are my factors of a times c? Well, what is a times c? Well, 3 times 9, so is 27. What are my factors of 27 that add to negative 28? Oh, well, this one's not too bad once I break it down like that, but it would have been harder to do it without knowing this process. So factors of 27 that add up to negative 28 would be negative 1, or just negative 1x, and negative 27x. Because a negative x and a negative 27x add up to negative 28x. The reason I'm putting these x's here is because I want this to match up what's here. For instance, some of you maybe even learned to multiply binomials by another binomial using this spatial method of a box. Well, the way we use this box method to factor a non-monic trinomial, we would then factor up. So what are my common factors of 3x squared and negative 27x? Well, they both have a factor of 3 and an x in common. That's the GCF of those two terms. Let's do these here. Well, x and 9 have no common factor, so it would be 1. And this is one thing you need to be careful of. When doing this box method, you take the sign of the box you're closest to. So you notice this I made positive because the 3x was positive. Now I'm going to make this one negative because the x is negative. Now let's do it sideways here. Well, this would be an x, the common factor, it's positive, and this would be a negative 9. So what ends up happening is that this is one of my binomials, x minus 9, and this is my other. Let's see if it works out. So 3x minus 1 times x minus 9. So we can now test out our answer by multiplying it to see if we get the same thing we wanted to above. 3x times x is 3x squared. I sometimes prefer to call it double distribution, but I know it's popular for it to be called FOIL, so I'll write out the FO first, then my outer. Now my inner would just be minus 1x or minus x, and then my last would be negative 1 times negative 9, which is plus 9. Okay, I then have my x terms that can be combined, and I get a 3x squared minus 28x plus 9. So I see this is indeed the correct factored form, and I got there by using the box method. Feel free to stop the video. I'll put one more example here in case you'd like to try it on your own, but I'll do one more here for us to take a look at. And the nice thing is this works with any type of factoring. It works with special cases. It works with, if you have a single binomial squared, you have a lot of flexibility in your application of this method. I'm going to throw another one though that is not a special case. This is going to be, wish I had some better examples, but this is the best I got for right now. It's a pretty good one. A 2x squared minus the 21x plus 10. Again, I was taught to just say, okay, well 2x squared is, 2 is prime, so I could just start by doing this and just think about it till it makes sense, which I like to do actually. It's a fun mental exercise. I could think, oh, well this is going, oh, okay, so I just figured it out. I believe it would be this. Let me see. Yes, because I'm doubling the negative 10 and getting a negative 1. But could we get that answer using the box method? Yes, we could. Systematically. Let's go. 2x squared plus 10. Drop those in. 2 times 10. What are my factors of 20 that add to negative 21? Well, that's just negative 1x and negative 20x. Maybe I should have got another better example because it's pretty similar to the last one. Factor up 2x, factor here minus 1, factor across x, factor across, take the sign there, negative 10, and you see it is indeed what we found here. Okay, if you're still with me, I got another one that's better for you. You could of course pause it and try it on your own, but I think I came up with a nicer example. So this one I would say is a bit trickier to do it the way I was taught because the first two had a prime a, 3 and 2. This one, I don't know if it's 4x and x or 2x and 2x. So it would take a bit more experimentation. So maybe this is one where I would choose also to use the box method. 4 times negative 49, well that's 98 times 2, that is, what is that? 98 times 2 is 196. Negative 196. So what are my factors of negative 196 that add up to negative 21? Interesting question here. And once I put these in here, so that multiply to this and add to negative 21. Well, it turns out, I believe it would have to be, oh yeah, because 6 goes into 190, or no, 7 goes into 196, I believe, 28 times. So it might have to be a positive 7x and a negative 28x that I drop in here. 7 times 28. I believe that's the case. It doesn't matter which box you put these in, you would end up just reversing which binomial ends up where. So let's see, factor up, that's just an x. That would be a negative 7, I believe. Factor across, that's a 4x. And this would be a positive 7. So the factored form would be 4x plus 7 times x minus 7. So that's one where maybe this was not the best. Maybe you would have to list a lot of factors of 196 before you got there. Maybe you would try, a number of things before you got to 7 and negative 28. But once you got there, it doesn't become too bad, because now we could multiply it out. I'll get a 4x squared minus a 28x plus a 7x minus 49, and we can confirm when we add those together we would get this. Hope this video was helpful for factoring non-monic trinomials, right? Thinking about the A, the B, and the C, and using those to get to this answer. I'm going to do one more here just because I'm having so much fun. I'll do one that's a special case that maybe we would have trouble with if we just stumbled upon it in the wild. So 25x squared. Let's take a look. Plus a 10x plus a 1. Some of you are saying, come on, Mr. T, I got this one in the bag already. I would just knock it out. I can see it's a special case product. But what I'm curious is, would it work with the method we've been using? Well, let's take a look. Because what are the factors? Well, I would do 25 times 1. That's pretty nice. What are the factors of 25 that add to 10? Yes, it's 5 and 5. And what we're going to see is, since these boxes are the same, we're going to end up with the same factor, which is why it's considered the special case. 5x, well, that's just 1 in common, 5x, and that's just 1. So this actually factors down to a 5x plus 1 squared. Let's check our answer to see if we can have confidence in this method. Wow, it even works for special cases. I sure hope so. 25x squared plus 5x plus 5x plus 1. Yes, that's the same as above if we were to combine those middle terms. Hope you enjoyed this video. Don't forget to like, dislike, subscribe, or unsubscribe depending on how much you liked it. And have a great day.